not sure what you mean by area under a curve or a function. Yeah. So it found us two things. Boy. So it found us, let's get this going, just the antiderivative. So that's just kind of being able to go forward and backward. And then it also found us the area. And that was kind of disguised, wasn't it? You were having to sum up all these rectangles, and pretty soon you just found, oh, that's just the area through integration. So the fundamental theorem of calculus must be pretty big, huh? It's fundamental, so it must be the big part of calculus. Actually ties together these two ideas. So the first one said, if I have some curve and I'm looking for this average rate of change, I take change in y over change in x. Would you agree where this is change in y and this is change in x? And that's going to find me the slope of the red line. Would you be okay with that? Okay, so now we're going to tie together this idea. So I kind of have that same curve. And now I'm finding the area under the curve. And so how do I find area under something? What do we end up doing? What was the definition of area, even of a circle, when we cut it all up? It was a rectangle, so we're going to look at change in x, and we're going to do what with it? How do I find area? Multiply by the change in y. So there's a relationship here. Notice we said derivatives and integration are exactly the opposite. You see division and multiplication? This means they're exactly the opposite. So today we're only going to do part one. There are two parts. Part one is the evaluation of an integral. So you've already done evaluation of integrals. Okay, but now I'm going to write it down formally. So it says, if f of x, notice it's lowercase, is continuous on this interval, what does that mean? Why do I want things to be continuous? That's saying I can take the derivative. The derivative must have been able to happen. Okay? And cap f. So we're going to kind of do this lowercase cap case again. Cap f is the antiderivative. So remember, you have to be continuous to take a derivative. So if it's continuous, you can go backward and find the antiderivative. Okay, it's the antiderivative of f of x. So who is f of x again? Lowercase f of x. Who's lowercase f of x again? Okay, is it the derivative or the original function? The original, what one is the original? Nope, lowercase f is the derivative. Uppercase is the original function. Okay, so that means I'm going to integrate who to get cap f out? If I integrate the derivative, the result of that is cap f of x. What have we been adding on to that? Right. So now we're going to learn how to do an integral when I have some a to b. Notice right there, I'm going from a to b. So let's kind of clean this up a little bit here. So I am integrating the derivative with respect to x. So let's go back in time a little bit. Who is f of x? And who is dx in terms of an integral? Who's my width? Who's my height? So you know that, right? What was the integral all about? Why am I integrating? What does that kind of look like I'm doing? It's a stretched out s. What is an s? Why am I using an s? I'm summing. So I'm summing all the little rectangles in the interval from a to b. Okay, so the evaluation says we need to know how to calculate this. When you looked at your last test, I gave you the values, and then you just use those end results. Now you're going to learn how to calculate it. And all you do is this. Cap f means you've taken the what? Why am I using cap f now? It's the antiderivative of the original function. Antiderivative of b minus f at a. Notice there is a subtraction sign. Now, why would I do that? Let's just look at a picture. Like, where would this come from? Okay, so I have some picture. Here's A, here's B. So this is f at B. So if I find f at B, I have found all of this shaded area. But I don't want to go to 0. I want to go to... So if I... Would you agree if I subtract this piece... Oh, gosh darn it. Let me fix this here. Let's see if we can go back. So if I take away this area, do I have from A to B? Okay, so that's really essentially where it came from. We're not going to prove it. That's what happened. Okay, so what happened to my constant C? Now I don't have an add C. What happened to my constant C? Let's try it. So I'm going A3 of F. Why again am I using a lowercase? That's going to be important. Why is it lowercase? Who does it actually represent? The derivative. So why am I using cap F? Minus. We had lots of errors with parentheses on the final exam. Why do I need parentheses there? Right. And lots of us were forgetting, and that's why your derivative rule minus f of x didn't work out. So what happens to your c's? So I'm just left with f at b minus f at a. So that constant c will actually cancel out. It doesn't matter where I'm at, the area will still be the same. Okay, so let's try a couple of these. So if I give you something like this, which you had earlier, okay, instead of adding up all those rectangles, we can now say that this is x cubed over 3. Okay, and I'm going to evaluate from 0 to b. Is everybody okay with that integral x cubed over 3? Okay, this is new notation. What do you think that solid line in the rear means? I have already done what? I've already taken the antiderivative. And now, who do I plug in first, b or 0? Yeah, I taught the top one. So it's b cubed over 3 minus 0 over 3. So do you remember when we were starting all of these when we began? We were starting it at 0. Okay, we were starting it at 0. So let's try the next one. If I was to integrate this, I'm going to get x cubed. Whoop, it is x cubed, so now I power up x to the 4th over 4 from 1 to 2. So who do I plug in first? Every time it's the same. What do I plug in first? So I'm going to get 2 to the 4th over 4 minus 1/4. What's 2 to the 4th? Isn't it 16? Isn't that right? So I'm going to get 15/4. So that would be the area. Now, I don't have any units on this, okay? So it's just kind of learning this antiderivative idea and plugging in some bounds. So let's try the next one. How would I integrate x cubed minus 4? Or, sorry, I'm telling you the answer. X squared minus 4. How would I integrate that? What would this turn into? And again, that line says I have integrated it. So who do I plug in first? Always the same one. What is it? So it's going to be 8/3 minus 8. And again, this parenthesis is going to be super important for you to remember. And then I'm going to get minus 8/3 plus 8. So when I go ahead and distribute this, it's going to cancel here. And now it's going to make that. So what do I end up with? Looks like 16/3 minus 16. Did I make a mistake? Are you all right? Okay, so notice I subtracted. So what do you notice about that area? 16/3 minus 16. If this was area, what would that say about this? It has a negative area. Let's look at a picture. So we can see it's a parabola that is moved down 4. And I'm finding from -2 to 2, so I'm finding from here to here. So what does a negative area really tell you? It's below the x-axis, right? So I could counteract that, okay, by switching the sign of everything. What's that? Yeah. You want to draw on my board. What are you going to draw? Are you already doing the next problem? Oh. Well, let's see what this does. You would have 0 area, wouldn't you? Do you see what he's saying? If it's symmetric, these two areas, this one being negative and that one being positive, remember it's area under the curve, it would cancel it out. So let's see what happens. That's exactly where I'm headed right now with this one. Okay, so this says you have the graph of sine. So let's get a picture of that. Here's the graph of sine. And it says I want to integrate sine. So I'm just thinking of antiderivatives right now. I'm skipping this word right now. I'm just finding the antiderivative from 0 to 2 pi. So if I integrate sine, what do I get? What's the integral of sine? Okay, is it negative or positive? What's the derivative of cosine? Is there a negative there? So I better put a negative there. Okay, so now I'm going to integrate it from 0 to 2 pi. So I always plug in b first, then I subtract the insertion of a. That's the evaluation. So what's the cosine of 2 pi? Oh, come on. You got to know that. So would it be -1? Because that negative there, it is 1, and I put a negative. 2 negatives make a positive. Would you agree? When I distribute, what's the cosine of 0? 1. And so what do I end up with this? So let's take a look exactly what Michael was saying. Okay, if this is 2 pi, would you agree the blue area is exactly the same as the green area and the area is 0? So we've got two different contexts here. One is just finding the antiderivative, 0. The other one is finding the area. So how could I do this problem? Graphs are going to be a big deal here. How could I do this problem to find the area? What could I do? Since it's symmetric, could I do this? Could I do that? And it's just double. Why did I stop at pi? I could have also done this, which is kind of interesting here. And then I could, would I want to add or would I want to subtract? Oh. Would I want to subtract because it's going to make it a what? I'll move here just a second. Theta d theta. Would that also counteract the negative on the area? So if I subtract a negative area, what does it turn into? A positive. Not wherever you want, where it's meaningful to say that that area should be positive. Okay, so that's why a picture is important. So if I went back to the one that you drew, okay, so you were going and you had this, what did you do? You went something like this, right? Is that, no, what did you do? Did it go down the other way? Could I do this? Would that work? So this triangle is positive, this triangle is negative. If I find that point and change the sign, then I'm good to go. Okay? So that's why picture is helpful. If it's symmetric, I can double it. If it's not symmetric, for example, this kind of looks symmetric here. So what if I did this, and I have a new one, and it's coming down like this, but it stops there? Would that area still be negative? Okay, so I would have to set up two integrals and subtract the negative area, so it would come out positive. So you do an adjustment. Okay, so let's look at the back side of your paper. Your homework problems are out of your book on this one. Okay, so there are some books back there. We can get some copies. Go ahead and get